Hello students, we are studying the lesson of gravitation and today we are going to study few points and these are very interesting points. So let's see which are these points. The first point is Earth's gravitational force, second is effect of Earth's gravitational force, then it is Earth's gravitational acceleration, then what is free fall, and last one will be Newton's 3 laws of motions. So I would like to request you that you can open page number 7 of your textbook, so it will be better for you to understand what will be taught in this lesson. So let us study about the first point, that is Earth's gravitational force. In your textbook, they have given you few questions first, so that it will be easy for you to understand what is Earth's gravitational force. So the question is, will the velocity of the stone thrown vertically upward remain constant or will it change with time, and how will it change? So if you throw a stone vertically upward, usually you have been playing with the ball by throwing the ball upward. So if when you are throwing any object upward, so will the velocity of the object, will it remain constant or will it change by the time? Or if it is changing, then how will it change? So if you want to answer this question, we have to see the picture here. In this picture, this is very easy, or it is explained in an easy way. The man is throwing the object up. So when it is thrown up, the velocity is shown by slowing down. Means the speed or velocity is slowed down here. And as it reaches up, at one point or at one place, the object stops. And after that, the object starts speeding up or falls down faster as compared to the first. So according to this, we can say that the velocity of the object will change. It will not remain constant. And how will it change? It will change by the time, and first it will go up slowly and it will fall down faster. Next question is, why doesn't the stone move up all the time? Why does the stone fall down, or why doesn't it move up and up? And second question is, why does it fall down after reaching a certain height? So obviously their answer is because of the Earth's gravitation or the Earth's gravitational force. This force tries to pull the object down and reduces its velocity. Okay, whenever any object is thrown up, it will reach a certain height, and as the Earth's gravitational force is acting on the object will fall down quickly. That's why the stone which is thrown up vertically will fall down, it will not go up. So you can see here in the diagram once again, the ball which will not go up, it will stop at a certain height, and as the gravitational force is acting on the object will be pulled down again back on the earth. Now, on what does the maximum height of the object thrown upwards depends on? So whatever object you are throwing up, at what height it will reach? This height, on what does it depend? This height depends on the initial velocity. Initial velocity means the initial whatever velocity you are using to throw the object up. Okay, that will be your initial velocity, and initial velocity is denoted by the letter U. Okay, when you are solving any numericals or the sums of this lesson, then you must know that for initial velocity you have to take the letter U, and for the final velocity the letter V. Now on the same page number 7, the last part or the last paragraph which is asked, that is about the, if the earth attracts an apple towards itself and the apple also attracts the earth towards itself, because the gravitation force means what? In the universe, any two objects, they exert the gravitational force towards each other. So if it is true, or if it is similar, or the concept is of the gravitational force, then why does the apple fall towards the earth, but the earth does not move towards the apple? So does an apple falling towards the earth's surface attract the earth, or only the earth is attracting, or the why doesn't the earth move towards the apple? Or we can see a similar question with, why doesn't the moon or the artificial satellite fall on the earth? So the answer is also given on the same page, and this answer is that the apple or the moon or the artificial satellite does not fall on the earth even if the earth's gravitational force is acting on them because of their velocity. The moon or the artificial satellite continuously keeps on moving around the earth. So because of this velocity, they does not fall on the earth. Okay. So if there is no velocity, then they would have fallen on the earth, which would have been a big disaster or the big threat to the earth. This will not happen because the moon is continuously moving around the earth with this particular velocity. Now let us go for the next point, that is free fall. Before we study about the free fall, let us see about what is the acceleration due to gravity. Acceleration we have studied in the last standard previous year, that is in 9th standard, and acceleration was denoted by the letter A. Okay, but here in this lesson, this acceleration is due to the gravity, that's why it is denoted by the letter G. Now here I have written here, that is G is equal to 9.8 meter per second square. This explanation you will get on the page number 8. Okay, this acceleration means what? In your textbook, page number 8, in the first paragraph, it is told you that as the gravitational force on any object due to the earth is directed toward the center of the earth, the direction of the acceleration due to gravity is also directed towards the center of the earth, that is vertically downwards. Okay, means whatever things objects will fall, it will fall vertically downwards. Okay, clear? And according to the Newton's second law of motion, the force acting on the body results in its acceleration. Means, for example, if you throw a ball down, the force which is acting on the object is gravitational force. So because of this force, there is acceleration in the object. Okay, the object gets the acceleration. Now as we are studying about the gravity, we will study about the acceleration due to gravity, and henceforth when you are solving the sums, you have to take the letter for the acceleration due to gravity, that is G. Okay, that we will explain further in this lesson. Now if you see the picture over here, the man is falling down. Okay, the skying it is. Okay, skydiving it is, and in this the man is falling down, but the speed which is shown, it is 9.8 meter per second square. Okay, so what does this mean? It means that the speed for any object which is falling down is same. Okay, let us explain how. Here in your textbook, page number 9, they have given you what will be the value of the G at a particular height of the earth. So if you are on the earth's surface as regular on the ground, so there also the value of the G is 9.8. If you go on the top of the Mount Everest, there also 9.8. If you go at the maximum height like an air balloon, then 9.7 it will be reduced. Okay, then if you go at a particular weather satellite, the orbits, then it will be 8.7, and as you go higher and higher, the value of the G will decrease. Now what will be the value of the G if you go inside the earth? So it will not go on increasing, it will go on decreasing. That part you will get on page number 8 and 9. Okay, as what will be the value of the G as you change the height, or as you change the depth of the earth or the object. Now about the free fall. So in short, or in the easy way, if you want to learn about what is free fall, then just see the picture over here. In this, it is shown that a feather and an elephant. So if you drop a feather and an elephant from same height, okay, at the same time, so then which one will fall first? So obviously we will say an elephant, but the answer is wrong. It's not an elephant. Usually the free fall means whatever objects fall on the earth, maybe it is lighter or it is heavier, both objects will fall down with the same speed. Okay, now if you compare these both objects, the masses are different, but if these two objects are thrown down or dropped down in the vacuum, then both objects will fall at the same time. Okay, no one is earlier or later, both objects will fall down. But usually what happens, that elephant will fall first and the feather will fall afterwards. So the reason is that this acceleration is due to the air. Okay, there is a air resistance. During the free fall, the frictional force due to the air opposes the motion of the object, and a buoyant force also acts on the object. So what happens actually, whenever you drop any object down, there is the air around the object. Okay, and this air creates the frictional force and it opposes the motion of the object, and the buoyant force is also acting on the object. So what is the meaning of buoyant force? Buoyant force means the force which is opposing. Suppose you throw a ball or a stone, okay, or you are drawing a water from the well. Clear? So when the pot is filled with the water, the pot will go down. At a certain time, there is a certain force which will push the pot up. Okay, or when a leaf is falling from a tree, there is a motion of the air, or the air moves around, and because of that, the leaf sometimes it goes up, sometimes it's come down. Okay, so this upward force is called as the buoyant force, usually in the water liquid form or in the air gaseous form. So thus a true free fall is possible only in the vacuum. So usually what happens, what is the meaning of the free fall? That if you drop any object down, it will come down at the speed of 9.8 meter per second square. Okay, the acceleration will be similar. It may be feather or it may be an elephant. For both the objects, the acceleration will be same. Both will come down with the same speed. But what will happen here? The air resistance or the frictional force which is created by the air, it will affect the feather more. So the feather will come down slowly, whereas the elephant will come down faster. Okay, so here the mass does not matter in the free fall. But for the free fall, the initial velocity will be 0. When something is falling down, suppose you are throwing a ball, the ball will fall down. So you are holding the ball up in your hand, that is the velocity of the ball is now 0, that is u is equal to 0, and the acceleration is g. Now the last part of the lesson I will take here, that is about the Newton's 3 laws of the motion. Okay, 3 laws of the motion given by the Newton, which you have studied last year. To the left side I have written the full equation, that is v is equal to u plus at, s is equal to ut plus 1 upon 2 gt square, and v square is equal to u square plus 2as or the gs. And in your textbook, the new formulas or the equations are given as v is equal to gt. Why gt only? Because u is 0. Okay, for all the free falling equations, all the free falling sums, u is 0. That's why it is u is not calculated over, not included over here. And in place of the a, it is written as g. Then s means the displacement or the height. S is equal to 1 upon 2 gt square. Here also u into t is equal to 0. Then v square is equal to u square. Again u will be 0, so 0 and 2 gs. Clear? So if you want to find out the final velocity, that is v, if you want to find out the height, or that is s, or if you want to find out the time taken by the object to fall, you have to use all these three equations. Okay, so this was about the all these terms like Earth's gravitational force, then acceleration, then free fall, and this Newton's laws. Clear? Okay.